Hello, let's continue our Sudoku adventure with Omitted by Crusader175. So this continues our Sudoku rules do not apply theme week. So definitely pay attention to the rules here. Today we have an octoquadri. So we need to fill the grid with 8 of the digits from 1 to 9. So we're going to be using some subset of 1 to 9 that includes all but one digit. So maybe the 2 is omitted. And we end up with all the, with 1, 3, 4, 5, 6, 7, 8, 9. Kind of interesting. So we don't know which digits are used. We just know all of 1 through 9 are used except for one of them. So 8 of 1 through 9 are used. All right. Now the digits must appear exactly twice in the whole grid. So we have a 4 by 4. So that means that there's a total of 16 cells. And since we're using 8 of the digits 1 through 9 twice each, that makes sense. So no digit appears once, no digit appears 3 times, etc. in the whole grid. All right. In addition to that, no digit repeats in a row, digits don't repeat in a column, and digits don't repeat in any of these 2 by 2 boxes. All right. In addition to that, we have Mathrax clues. Each pair of diagonally opposite digits surrounding a circle must sum to the given value. So this is 10. So for example, we could do 2, 8, because 2 plus 8 is 10. All right. And then this would also add to 10. So maybe 1, 9, 2, 8. This would be one way to do that. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I don't know if this is the best way to start, but it's interesting because we know the sum of the entire 4 by 4 grid, which should tell us which digit is missing. I'm just going to use a calculator so I don't make any mistakes, but I think you could probably do this in your head as well. So it's going to be 9 plus 10 plus 11 plus 12, doubled because it's the 2 diagonals. So that adds to 84. So that means that our digits from 1 to 9, twice each, sum to 84. So if we divide that by 2, that means our digits 1 to 9 sum to 42 without repeat. And that means they're missing the 3 because 1 through 9 sums to 45. Good number to know if you do 9 by 9 Sudoku variants. And in order to have 1 through 9 missing one digit add to 42, we're missing the 3. So we do not use 3s in this puzzle. I think that's useful to know. So adding to 10 can really use any digit. We just can't do 3, 7. So we know there's no 7 around here. So we got to put 2 7s elsewhere. These add to 13, which is interesting. Or sorry, these add to 13. So 13 is pretty big. Not that big, but we can't do anything lower than a 4. So we're either going to be 4, 9, or 5, 8, or 3, well, not 3, 7, sorry, 4, 9, 5, 8, or 6, 7. That is anything but 1, 2, 3. So I suppose that's not all that exciting. But this is not going to be a 7 because we don't have a 3 in the puzzle to add to 10. But this could be 4, 6. It cannot be 5, 5. This could be 6, 4. This could be 8, 2, or 9, 1. All right. Now these add to 12. So we could do 4, 8. We could do 5, 7, 6, 6 we can't do, 7, 5 we could do, 8, 4 we could do. We cannot do 9, 3 because there's no 3 in the puzzle. This has actually been a useful little piece of info. And we can update these 13s as we go. So here, in order to get to 13, we can do 4, 9 or 5, 8. But we can't do 7, 6 this way. So that's not a 7. 7, 6, 8, 5. We are not 4, 9. Okay. And then here, we could do 4, 9. We can't do 5, 8. We could do 6, 7. We can't do 7, 6. And we could do 8, 5 or 9, 4. Okay. So now here, adding to 11. I wonder if there's a better way to do this. But anyway, I'm on it already. 4 plus 7 is 11. We could have the 4, 7 pair. We could do 5, 6 to add to 11, or we could do 9, 2. And here we add to 9. So this definitely isn't 9, which means this definitely isn't 4, which means this definitely isn't 8. Okay. Got to kind of cascade these sums here. 5 plus 4 is 9. 6 plus 3 is 9. We don't have 3. So that's not 6, meaning that's not 7, meaning that's not 5. I have to do this very carefully. Okay, and then 8 plus 1. Okay. So along this diagonal, I've got... Okay, this is a 5, 8 pair. to add to 13. It's the only way we're adding 13 is 5 plus 8 here. So that means that this can't be 8, because if it was, these would both be 5, and that's no good. So wherever the 8 is, this sees the 8. And wherever the 5 is, this sees the 5. So this isn't 5, and that's not 8. Basically, we're not doing a 5-8 pair with a 5-8 pair. Because it would actually be 5 plus 5 and 8 plus 8. All right. So I removed 8 from here, which means this can't be 2. And I removed 5 from here, meaning this can't be 6. All right. What's next? We know there's no 7 in here. If this had a 7, it would be 2, 7. Do I have anything else going from here? I know I need another 5 and another 8 somewhere. Doesn't seem super useful. Let's see, 4, 5, 8, 4. Interesting. 4 would force this to be 4, and then there'd be no more 4s in the puzzle. So let's think about that, because there's 2 ways that this resolves. So it's either going to be 4 with 5 here, and then 8 with 4 here. So 4, 5, 8, 4. And that uses up all the 4s. So there's only 2 4s in the whole puzzle. Or it's going to resolve as 1, 8, 5, 7. Which isn't as interesting. So I wonder if the fact that 4s get used up is a problem. So if this was 4, 5, 8, 4, then these wouldn't be able to be 4, 9. So they would be 6, 7. This would be 6. This would be 7. Do I go farther? This would be 2 and this would be 4. Oh yeah, that's no good. Oh yeah, the 6 here is no good, because we already used 2 of our 4s. So I guess my point is, if this is 4, then through this chain, this ends up being 4. And now this can't be 4, 6. It has to be 1, 9. But yeah, this would then be another 4. Or another way to put that would be, if these were both 4, this could not be 4. This wouldn't, yeah. Okay, let's put it this way. If the 4s are used up, this has to be 6, 7, but the 6 requires a 4 up there. There's a few ways that this breaks, but anyway, we can't do that diagonal. So this actually has to be a 1, which resolves this as 8, 5, and 7. Okay. So this is not a 1 because of the row. This isn't a 7 because of the row. So 1 removes 9, and 7 removes 4, or lack of 7 removes 4. This is a 4, 6 pair now. Okay. Now this does need to add to 10 still. It's not doing it with 4, 6. So 1, 9 is possible, but this would be 9, this would be 1. 2, 8 is possible, but this would be 2, and this would be, oh, sorry, other way around. This would be 8, this would be 2. 2, 8. 3, 7 is not possible because there's no 3 in the puzzle. Can't do 4, 6. I can't do 5, 5. Okay. These need to add to 9. We're not 1, 8. We could be 2, 7 either way. Can't be 3, 6 because there's no 3. And we could be 4, 5, I believe. 2 of each digit feels like something I need to pay more attention to. So there is another 5 somewhere. I suppose this could be 5, 6. I can't think of any reason that would be a problem. We already know there's 1, 6 over here. So there's one more 6. Ah, okay. So there's one more 6 in the puzzle. We have this 4, 6 pair, but where's the other 6 go? We know it doesn't go in these 2 cells because this would be 6 plus 6. That's no good. In the same box, you can't repeat the 6. So 6 can't go in any of these. So actually, this is our 5, 6. This is 6, this is 5. That uses up our 5s and our 6s. This can't be 5, so that's not 4. So 5s are done. Maybe I should like green the ones that are done. 5s are done. 6s are done. 6 is somewhere in there. All right, I am going to need another 8. Maybe I should just think about how we're adding to 12 first. We can't use 3, so it's not 3, 9. In fact, where are the 2 9s then? Okay, so if we can't put 9 in here, then these are the only 2 places for 9. So that helps a lot. These are 9s. This is a 1, so 9 is done. 9 plus 11. 9 plus 2 is 11. That's not 2, so that's not 7. 9s are done, 6s are done, 1s are done, 2s are not done. And we're not putting a 2 on a 12 sum. So this is our other 2. So it's 2 plus 7. So 2s are done and 7s are done. I do need another 8. So this is 4, 8. Okay. I don't think I need to color anymore because we've finished all of our... How does this resolve, though? Oh, the 13 here. Okay. 9 plus 4 is 13. That's 6. That's 8. That's 4. I was like, how does this resolve? All right. Really neat idea, Crusader. I enjoyed that a lot. And I think it did help to just immediately know from the sums that we weren't going to use the 3. I think that gave us a nice in. A little bit of whittling down, and then this diagonal was interesting. We couldn't do 4, 4 here because it broke other stuff. I don't know if there was like a cleaner way in or a cleaner way to think about that, but it worked out for me. Cool. Well, let me know how you did, and if you enjoyed this, want to leave a like, subscribe, and a kind comment below.